Chapter 9 Review Guide. In this chapter, we learned a different way to express a point. Instead of using x and y coordinates, we now can go to a certain degree and then go out a given radius. This is expressed as r, theta. Polar coordinates are often used in navigation as the destination or direction of travel can be given as an angle and distance from the object being considered. For instance, aircraft uses a slightly modified version of the polar coordinates for navigation. Polar or trigonometric form of a complex number. Z equals r cosine theta plus I sine theta. In this equation, r represents the magnitude / modulus of z, while theta represents the argument of z. When using polar form, r is greater than or equal to 0, while theta is greater than or equal to 0 and less than or equal to 2 pi. Changing from polar to rectangular form or rectangular to polar form. R squared equals x squared plus y squared. X equals r cosine theta. Y equals r sine theta. Product and quotient of complex numbers. Z1 equals r1 times cosine theta 1 plus I sine theta 1. And z2 equals r2 cosine theta 2 plus I sine theta 2. Then, z1 times z2 equals r1 times r2 times cosine of theta 1 plus theta 2 plus I sine times theta 1 plus theta 2. z1 divided by z2 equals r1 divided by r2 times cosine of theta 1 minus theta 2 plus I sine of theta 1 minus theta 2. R cannot equal 0. De Moivre's theorem. Let z equals r cosine theta plus I sine theta, and let n be a positive integer. Then z to the n equals r to the n times cosine of theta n plus I sine of theta n.
In this question, we want to plot the polar coordinate at its given point, 2, 45 degrees. So I went up from the x-axis, I went up 45 degrees in quadrant 1, and then I went out 2 spaces. So that's a pretty self-explanatory problem. That's all you really have to do. You just have to know that the 45 degrees just go halfway in quadrant 1 and then go out 2 spaces. In this problem, we want to find the rectangular coordinates for the point 5, 120. You can either do this on a graph or you can do it with these formulas. So for the x, we do r times cosine theta. So we do 5 for r, because we know it's r comma theta in the original point that it gives to us. And then we know that it's 120 degrees. So you do negative 5 times cosine of 120. You then do 5 times negative 1/2, because you know that cosine of 120 is 1/2 on the unit circle. From there on out, you just know that it's 5/2 for x. Same thing for y. All you have to do is 5 times the sine of 120, because the formula for y is r sine theta. So then we know that it becomes 5 times root 3/2, because we know that the sine of 120 on the unit circle is root 3/2. And then our final answer for y will be negative 5 root 3/2, which brings us to our final in the form 5/2, negative 5 root 3/2. For this problem, it wants us to find the polar coordinates for the point root 3, negative 1. So the point of this one is to understand that we're looking at a 30, 60, 90 triangle. So if we look over here and we see our 30, 60, 90 triangle, we know that across from the 30 is x, across from the 60 is x root 3, and then across from the 90 for the hypotenuse is 2x. So we go back to here. We know that we have to go to root 3, 1. So we know that that's the 30 degree in quadrant 4, negative 30 degrees. And then we can then fill out the rest of our triangle. So it's root 3 across from the 60, negative 1 across from the 30, and then 2 across from the 90. So then we know that our final answer is 2, negative pi/6 in radians, because our radius is 2, because that's the hypotenuse, and then we're going out negative pi/6 from the x-axis into quadrant 4.
For question 4, you start out with x squared equals 4y. You're trying to change this into polar form, so you need to get rid of the x's and y's. To do this, first you know that x squared equals r squared cosine squared theta. Then you know that 4y is also 4r sine theta. Once you set those equal to each other, you can divide by r, leaving you with just r cosine squared theta equals 4 sine theta. Question 5 is very similar, but in this one you are changing from polar form to rectangular form. In this you want to end up with all x's and all y's. To start, you multiply both sides by r. This leaves you with r squared equals 10r sine theta. After this, you use the formula x squared plus y squared equals r squared, and you substitute r squared with x squared plus y squared. Then you know that 10r sine theta equals 10y. You set them equal to each other, and that is your final answer. The next one has to do with graphing complex numbers. Graphing complex numbers is actually very easy. Negative 2 minus I might look complicated, but all it is negative 2 comma negative 1. To graph it, you just graph it like any other point, going negative 2 over negative 1 down.
Writing the complex number in polar form, 1 minus I root 3. First, you graph 1 minus I root 3. It should look like a 30, 60, 90 triangle in the fourth quadrant with the hypotenuse equaling 2. This forms a 300-degree angle. The complex number should equal 2 times the cosine of 300 degrees plus I sine 300 degrees. Finding the product and quotient of complex numbers. Find the product of z1 times z2. First, multiply 3 times 2, and then add 20 degrees and 40 degrees. It should look like 6 times cosine of 60 degrees plus I sine of 60 degrees. Then evaluate cosine of 60 degrees and I sine of 60 degrees. Cosine of 60 degrees is 1/2, and I sine of 60 degrees is I root 3 over 2. Then distribute the 6. 6 times 1/2 is 3, and 6 times I root 3 over 2 is 3I root 3. The final answer is 3 plus 3I root 3. Finding the quotient of z1 divided by z2. First, divide 3 from 6. Then subtract 25 from 70. It should look like 2 times the cosine of 45 degrees plus I sine 45 degrees. Then evaluate cosine of 45 degrees and I sine of 45 degrees. Cosine of 45 degrees is root 2 over 2, and I sine of 45 degrees is I root 2 over 2. Then distribute the 2. 2 times root 2 over 2 is root 2, and 2 times I root 2 over 2 equals I root 2. The final answer is root 2 plus I root 2.
How to solve a problem using De Moivre's theorem. Let the problem be evaluate negative root 3 over 2 minus I over 2 to the fourth power. First, you will need to convert this equation to polar form. So we will first draw a triangle to find out r and theta. This will be our triangle. This is our triangle because you will go over to the left, negative root 3 over 2, and you will go down negative 1/2. Then you can tell by this that is a special 30, 60, 90 triangle, and so we will be able to find the r, which is equal to 1. By the placement of this triangle, we can tell that the theta would be 7 pi over 6. To bring this into polar form, we can write it as z equals 1 times cosine 7 pi over 6 plus I sine 7 pi over 6. Then to apply De Moivre's theorem, we will take the exponent 4 and put r 1 to the 4th power. We will then take theta 7 pi over 6 and multiply it by 4 both here and here. When we actually multiply and put 1 to the power of 4, we get that z to the 4th equals 1 times cosine 14 pi over 3 plus I sine 14 pi over 3. To put this back into complex form, we will need to draw another triangle. Based off the given theta from here and here, we would need to go around the plane twice and then over to 2 pi over 3, where it would be root 3, 2, and negative 1. So we can tell that cosine of this is negative 1/2. And we can tell that I sine of this is root 3 over 2. So our final answer is negative 1/2 plus I root 3 over 2.